Welcome to Make Made Simple. Today I will be solving two questions from Beer and Johnson's book. So the first question is example 2.1. In this example, we are given two forces which are acting on a bolt A. Determine the resultant. So the two forces are like this: 20 at and 25 degrees. We have this point A here, and one force is acting like this, another force is acting like this. This is 20, this is 25. We have to find their resultant. So, to find resultant, we all know that we can use the triangle rule of vector addition. So, we will first make this triangle rule of vector addition. First, we will make uh, the vectors in tip to tail fashion. So, this is a vector, this is another vector, this is acting at an angle of 20 degree. And this is acting at an angle of 25 degree. 25 degree, mind you, from this vector. So it's not from this line 25 degree, no, it is from this line. So this is 25 degree. And the resultant vector is this. So what is 180 minus 25 degree? That would be this angle. That is 165. 155, sorry. So this is a triangle. We have applied the triangle rule and made this. We can give this angle alpha and this beta. Although we won't be using beta, we will just be using alpha. And we know that it is given in the question that that the two vectors P and Q are 40 and 16 Newton. So this is P equals 40 Newton and 60 Newton. 40 Newton. This is Q equals to 60 Newtons. So we can write here their magnitude. This is 40 and this is 60. So now we will apply law of sine, sine rule. So first we had applied triangle rule of vector addition. Now we will apply sine rule. So sine rule says that r by 155 degree equals 60 by sine alpha. So we write it here. R by sine 155 degrees equals 60 by sine alpha. Now we don't know alpha and r. So r we can calculate by law of cosine. R is equals to law by law of cosine. 40 square plus 60 square. 40 square plus 60 square minus 2 into 40 into 60 including the included angle. That is sine 155 degree. Sine 155 degree is the included angle. So we write it here sine 155 degrees. And you calculate this, it will come as 97.73 Newton. Now we know R, we know sine 155 60, we can calculate sine alpha. So from 1 we know R is equals to 97.73. So sine alpha would be sine alpha would be 60 1 sine 155. 60 sine 155 divided by 97.73. This value, by this value we can calculate A. A would turn out to be alpha would turn out will to be A. So this is A, this is B, this is C. So sine alpha would turn out to be, or we can say angle A. Here also angle A. Alpha is this. This hole is alpha. This hole is alpha. Sine A equals to that, and A would turn out to be 15.04 degrees. A would turn out to be so this is a magnitude of A. So this is A that we have got. But the resultant, when we write resultant, it should be from a given axis, from a predefined axis. So this is the x-axis. From x-axis A is A, we know A. This one A we know that is 15.04 degrees. To calculate alpha, we'll do alpha is equal to A plus 20 degrees. 15.04 plus 20, that would be 35.04 degrees. Answer, alpha is here and R alpha. So this is acting in this fashion. Or we can write it as in R we have got 97.7 degrees. R equals 97.73 degrees. 97.73. So this is the answer. So this is the answer that we have got by first we applied triangle rule of vector addition, then we applied sine rule, then we applied law of cosines and got 97.73 Newton angular magnitude of the vector. Then we applied from equation 1 we got sine A, sine A, and mind you sine A is this angle. This is angle A. So when we have got angle A, we add 20 to it to get alpha. Alpha is this whole angle. So that becomes our final answer. Alpha is equal to this 35.04 degrees. Okay. Okay, so that's all for today. If you have liked the video, please like the video and subscribe to the channel. I'll be taking up the next question in the next video. Thank you.